Okay, so we are moving on to numerical integration and differentiation. Very, very important. These things, because when you get here, then the confusion starts from here. It's not difficult, but if the question is being specified, that use this, use that, there is the problem. So here we have two things that will be considered here. We have the discrete variable and the continuous function. The discrete function and the continuous function. Discrete and continuous. Yeah. So you see here we have functions that we drew when in calculus. We have continuous functions that we drew and some discrete functions. And at this place too, we are going to consider about three types of integrations here or differences here. We are going to talk about the SDD, the BDD, and the CDD. That is the forward divided what? Difference, and then we have the one. So I'll call you back. I'll save your number. Then we have the backward divided difference. Then we have the central divided what? Difference. All these things are something that we know from our number plane. You see, in the number plane, if you have to sketch or if you have to draw a function, you see, always it is linear. You have to draw a certain function in the form x plus y, or you have asked to draw a function like this: x is equal to y. You see that the x is equal to, so when you draw this function, then either you get this or you get a line like this. Is that clear? Yeah. You can have to find a gradient of this line, and the gradient of this line is any point that you take on this line, you get a gradient. Any point that you take on this line, if you calculate the gradient to this, you get the same what? Gradient. That is slope. And the gradient here is the same as the differentiation. Is that clear? So if I find the gradient of this line, the same as differentiation or differentiating the function. I've differentiated the function. Is that okay? So the slope, the gradient, and the other things, they are all the same as the differentiation. So the first one we are going to consider here is the forward divided. I will show you some differences in these things, how to identify them easily. Because if you have gotten a question in the examination hall and they ask you to find the value of this or solve this question using the forward or the backwards, how do you identify? How do you go with the formula? That's the problem. Because each of them, in all the cases, they are different. You can't use this formula for this formula for that. But they are also many. If you are not careful, you combine them, and at the end of the day, you get everything wrong. So let's take the first one, the forward divided difference. That's the first one. I'm going to draw a diagram on the board. So assuming that if I have this, I have a line process in this form. Let's let me here to be my y prime. Here will be y prime. Let's say here is my xi plus 1. So if I write the f of x the same as y, so you know it. How do you find the gradient of this line? How can you find the gradient of this line? This one is called forward because the line is heading towards the. Exactly. That's the forward. The backwards is like this. The backwards is like this. The forward is going that way. So please, how do you calculate the slope? Change in what? Y over change in what? That is the other way is y1 minus y2 over x1 minus x. This one is correct though. If I write this one, y2 minus y1 over x2 minus x1, they are all correct.
They are the same.
They are all the same. So let's see. So my f prime of s, that is the differentiation. It's the same as finding the gradient. So this one will be equal to So change in what? So what they change in y? We got a change in y. The difference. This the. We want the length of this. Is that not it? So to find the length of this, what do we do? So if this one minus this, is that not it? So we say that y I plus the 1. Please, I use this one to differentiate between this and that. The I and the I plus 1, they are nothing. Just to make the distinctions of this and that, this point and that. Minus the. Is that not it? Because you get a point, you subtract this one from this, you get the difference here. All over. So you subtract this one from this, you get the length of that. Is that not it? Yeah. So we have the x I plus 1 minus x1. So that is the first one. That's the forward divided difference. So to find the difference between that's the gradient. Here we are just finding the gradient. Please, when we get further, this text will change. So that's why I said that let's pay attention here. So when we are going further, the integration sign may make something change here. So and the backwards also. The backwards divided difference. Number 2. That one too, if you have something like this and the line is like this, it's also in this form. We have here, we have there. So you see the first point here will be what? That is the SI. Here will be the YI. Here will be what? SI plus what? 1. So here will be what? The first point will be what? Y. Is it Y1? Yeah. And here will be what? YI plus what? 1. Let's see. It's the same diagram, but this one is this way. So to find the gradient of this line, it will be what? Yeah, what will be the gradient now? It will be this one and that. Is that not it? Yeah. And here will be y. The y1. So it will be y1 minus this. But it's yes, y1, yes, y1 plus 1. So it will be this minus that, not it. So y1 minus yi plus 1 over xi.
No.
Yes. So here will be yi1. And here will be yi plus 1, right? Yes. No. This one is decreasing.
Then it should be minus.
Yes, yes.
It's my man.
Y I minus 1. Y I.
So here will be what? Okay. yi minus 1 minus. So it will be this one minus that. That one is. So yi minus. This one, the difference between this one is that this one comes here and this one goes here. The backwards. This one is the first one and it goes this way. So it interchange. It's interchange. But the forward one, this one comes before this. So it's yi minus 1. Let me see if what you are saying is, I can take it like that. I'll explain to you. Is it correct?
Change in that boundary.
Huh? Change in our boundary, the negative.
The negative 2 million. Madam, I'm going to come.
Okay, so
What?
so why here is negative 1? Okay, so please listen. If we are from here coming back here, please listen. It's backwards, means that we are coming backwards. So here is xy. So what do? If we are coming backwards, we subtract what? 1 from the preceding ones. Is that clear? That is why here is xi minus 1 backwards. So if you are going forward, we add 1 to the si. So for instance, if you draw a Cartesian plane and we have label here 1, 2, 3, and 4. If you are to get to this one, what do? We add 1 to this to get this. To get the other point, we add 1 to this. Exactly. If you want to get back to here, what do? We subtract 1 from this.
No problem. How we explain why?
It seems like I made some small mistakes. So we are deciding we are coming down. Is that not it?
When you have the diagram, you have to select your initial point. Yeah. So for this one, if you select our initial point, the back one, we select our initial point. Yeah. From that, then we have to select the next point backwards or at the back of the point we selected. Yeah. So if you have to do that, then this one is correct. The first point we select will be yi or y1. Then the backward of that point is going to be the yi minus 1. So this one is correct.
So we are starting our initial point to be what there?
Yes.
Why? Okay.
Then we take the backward.
Yes.
Then the forward one you select the point in front of it.
Okay. Please, are you okay?
No. Very good.
You are telling you did everything like this. I mean, he changes there. So that is why it has created the conflict.
You have to get in one of the
Yeah, in our time it was that like this, like this. So in your book, we are all like foil like this, foil like this. That's why it has created the convictions here. Oh please, oh yeah, let's stick to this.
So even if every day if you are not looking at your man, then after the meeting.
Okay, so there's no consistencies in the notes. So what he gave us was like this. That is why the differences are coming from your book. Is that clear? Sorry. But what the man is saying is the same thing. So we chose our initial points here. And here to our initial point is here. And so if we are going to hand, so it will be I minus 1. So that is it. So we chose here to be our initial point. Please, okay, that's why here is SI. So here will be what? The YI. So we are going to the left hand side. We subtract 1 from the other one. Please, let's go by this one and retrieve. Please, let's go back. The CDD. And the CDD too, the same thing. It's the same. It's like the same thing that I'm drawing. Yeah. Okay. Please forgive me because the books there are some. You know when you go to class, certain times you see that there are some things you have to keep quiet and watch. That is central divided theory. Yes, please.
This is backward. Our initial is SI minus 1. The final is the SI. This is I and YI minus YI minus.
So it's supposed to be what? Yes, please.
Let's put.
I should change it.
Let's put.
It's the same. So the gradient is not specifically at one side, but whatever you do here, the one I wrote, no, it should be the same. Y2 minus YY, the same as saying that YY minus Y2 over S1 minus S2. Please, I beg, let's continue like that because certain times we also get confused in the class. So it's the same. Let's continue. Okay, the CDD means the central divided theorem. The central divided theorem. So we are comparing this one to that. So if you have a middle point here, let's say here is the initial one. That's the SI. Coming back on here, we have SI minus 1. So here will be what? XI plus what? 1. Is that okay? So here will be YI. So here will be YI plus 1. And here will be what? YI minus 1. We have the Y and the X. Yes, we
will
do.
make the top yi plus 1, and that one yi minus 1 rather. No, the y.
Yeah. Please. You see, when you are taking pair of numbers, you see, when you are plotting these are the pair of numbers in the meet here. So the one I've learned from this point is that always the points here and the here, they should be of the same. Exactly. The points here and here should be of the same. And the points at here and here. You see, when you are plotting a point of pairs on a Cartesian plane, you see, you pick two different pairs, the x and the y. For example, if you are finding the gradient of A, B, here x 2, 5, and B 3, 6. C we have we have negative 3 and 4. To find the gradient, you can choose these 2 points to find the gradient. Exactly, but you can't choose this point plus this to find the gradient. But are you okay? And so these 2 pairs is what we are talking of. So this should go with this one, this should go with this one, and this one should go with this one. So to find this center here, what do you do? To find the gradient, to find the function f prime of x. As this, what do we do? At this point, how can we find this point? The middle, the center of the. So it will be this divided by 2. Exactly. But here to find the gradient of the whole of this one is this one minus this. All over what? This one what? Minus that. Are you okay? Or this minus that. This minus that. All over this minus that. They are the same. You get the same answer. So it's either yi plus 1 minus yi minus 1 all over x I plus 1 minus x I minus 1. Please, what I've written here, you can just interchange them. But when you interchange them, they must follow each other. Please, are you okay with this one? So to find the gradient of this one is this one minus this over this minus this over this minus that. We get this. That is the central divided theorem. Use the central distance and formula way. So let's try to use them in our mind. But how to identify them is the cloud. And the last one aspect of this is the continuous function. And when you have, you see, these things are very, they are two different things. You see, when it is a discrete, this is how we do it. That is where we can, you see, in the other GHS, we can find a gradient using 2 points. That's a discrete one. But when we talk about continuous function, that is where we go to the, we use the first principle and the other things in differentiation. Do you remember? Do you remember the first principle? Aha. That is the f of what? The limit of what? Minus f of s all over h. That is the continuous function. Please, are you okay? That is what? A continuous what? Function. But the discrete one is what we have done here. Then when you have a point that you plotted on the Cartesian plane, then you pick 2 points to find the gradient. That is called a discrete. That means that when something is discrete, we know the exact value of it. Please, are you okay? We know the exact value. We know that this one is 2, this one is 5. So we can pick those 2 points to find the gradient. So when the function is continuous, like it goes like that, it's a curve. How do we find the gradient? That is why we call something slope. It is just coming down. I remember in class 1. Then you do a certain thing like this. Then you draw a certain like pass here. You remember? It's a continuous function. So you see that we are finding the gradient, the slope of this line. So it will just push it to this line. That's why we say that it's touching this one infinitesimally. It's touching, it's coming closer, but it won't touch it. We are finding the gradient at which this gets to that. So are you okay? So that is it. So same thing as the continuous function. The same thing as what? The continuous function. This one we are going to use the first principle always. But here in the book, the way they use it, you never see that it's the first principle because you don't use the h. But it's the same thing. That's the change in x over the minus f of s over delta s. It's the same thing. But here we have replaced that one by delta s, whereby instead of using the h. Is that okay? That is a continuous function. So if you have the forward divided difference on the continuous function, that's the FDG. This one is the forward divided. This one is called the continuous function. This one is called the continuous function. So if we have this, we know here to be our f of s. Let's have this one is our f of x, and here is our f of change in x plus what? X. Or x plus change in, let me write it so that you see it well. Change in x. So when you trace here, you get a value. When you trace here, you get another value down there. So let's assume that here is x, and here is x plus change in x. So here we are saying that to get the value of this change in s and s plus change in s, we want, for instance, if you have a value like this, from here we have 1, 2, 3. It means that to get this number, the difference between this and that, what is the difference between this and that?
1.
It's 1. So we are saying that s plus change in s plus the difference between this, you get the number. Is that not it?
Yeah.
So when we have x here, so to get the other number here, is this number plus the change, the difference between the preceding number, you get what? The number here. That's the change in x. Please, are you okay? So if we have 1 here, 2 here, 3 here, here is the x. Let's assume that is our x. Here is our x plus change in x. Is that clear? So what is the value here? Here is 1 for the x. The difference between 1 and 2 is what? That's the change. So add 1 plus 1 is what? We are getting 2. So that is the meaning of what? S plus change in x. Please, are you okay? So that is it. So how do we differentiate this function in calculus 1? This one is calculus 1 above differentiation. This one we prove. Do you remember that you proved this function? Didn't you establish the proof?
They did.
You went and sketched the thing somewhere and brought it. I remember we did the same thing. So let's find the f prime of x. So the f prime of x is equal to what? is f of x plus change in x minus f of what? All over the change in what? X. So this is called the first principle. But this one you prove to us. So if you want to fill up, you can go and look for how they prove it. It is go to next, it is there. So you prove it, you feel more happy when you are establishing a proof like this. It is not easy, but it is there, you can prove it. Yes, please. This one. This one you are putting it first. Sometimes you see the questions are in two folds. Under this one. Like presentation. I'll pick a question and this is how it's done. Please, let's pick a question here. Let's take a question before I come back to the continuous here. So find, let's write example. Find f prime of 3. Let me